Okay.
Hi everyone, so today we're going to be working on a problem using Newton's law of cooling, and the problem reads, just before 6 p.m. students entered the classroom to find Mr. Fies dead of an apparent homicide. Everyone said they saw it coming. At 6, the temperature of the body is 80 degrees, while at 7, it was 75. If the room is kept at a constant temperature of 70 degrees Fahrenheit, what is the time of death? So first, we're going to start with part A, and we're going to find the value of K. And here, for the T ambient, because it was the constant temperature, we're going to put 70 plus 80, because it was the degree of the body when it was found, minus, again, 70, e to the negative k, 1, because it's been exactly 1 hour from 6 to 7, and because of that, we're going to equal all of this to 75. From here, we're going to subtract 70 on both sides, and that'll give us 5 equals 10 from also subtracting 80 minus 70, e to the negative k times 1. And now we're going to divide by 10 on both sides, giving us 1/2 equal to e negative k times 1. And to be able to bring this down to work with it, we have to find a common base and take the natural log of both sides. So we take the natural log of 1/2 and equal it to negative k times 1. And now, to get the negative out of the k and work with the 1, we divide by negative 1 on both sides. Therefore, k is equal to the natural log of 1/2 divided by negative 1, which is approximately equal to 0.69315. And now we're going to plug this back into the problem, except for part B, being that we have to find the time of death to the time of discovery to the nearest 10th, we're going to be using the average temperature of the body, which is 98.6, equal to, again, the ambient constant temperature 70 plus 80 minus 70 e to the negative 0.69315 times t, because that's what we're looking for. And we're going to subtract 70 on both sides and get 28.6 equal to 10e to the negative 0.69315 times t. And again, divide by 10 on both sides and get 2.86 equal to e to the negative 0.69315 times t. And now, again, to be able to work with what is in the exponent, we take the natural log of both sides. The natural log of 2.86 is equal to negative 0.69315 t. Divide by k on both sides. Therefore, t is equal to the natural log 2.86 divided by negative 0.69315, which is approximately equal to negative 1.5. This can also be interpreted as an hour and 30 minutes from the time of death to the time of discovery. And that being part B takes us into part C, which for part C, we have to discuss and determine the approximate time of death. So the body was found at 6 p.m. Subtract 1.5, because that's how much time has passed from the time of discovery since the time of death. And that gives us 4.5, which is equivalent to 4:30 p.m. And that was the time of death. Thank you.